Greetings, algebra students. I am here to teach you lesson 6-4. Yes, I didn't want the day to sneak away without you getting to learn what you need to learn. So I made you a special video. All right, I know you're thrilled. So we have been talking a lot about systems of equations. We've been talking about when you have two equations, two linear equations, which are two lines, and how to find solutions for them. And we talked about graphing them to see where they cross. We've talked about using substitution to solve to get the coordinate that they cross at, and we've talked about using elimination to solve and see what the coordinate is that they cross at. So today we're just talking specifically about classifying some of these different types of linear equation systems. Okay, so let's take a look. You're going to want to have your highlighter out in different colored pens for this one so that you can clarify the difference between them. So the main way we started is we started with a situation where we took two different graphs, two different lines, and we said, hey, we're going to graph these and we're going to try to figure out where they intersect. Because this point right there is my solution. And as it says right here, there is exactly one solution. When you have a situation that's exactly one solution, sorry, I'm just looking for different colors here, that is called independent. When you have a situation where you have, well, I'll get to it in a minute. So that's just straight up how we're going to do this one. A one solution means that it's independent and it's what you've been doing. Okay, this is the majority of what you've been doing. We have done some of these, I believe. I'm kind of jumping ahead, and we haven't taught a couple of lessons yet, so I'm going by my memory from last year. But anyway, the other type of a one is where we graph a line. So here we go, we graph that same line. And then you graph another line. And what happens? It's on top of itself. Okay, it's the exact same line. And we call that a dependent when it overlaps like that. And that, if you notice, has how many solutions? Infinitely many solutions. The last option we have is where you have, again, our original line here, and our second line runs parallel to it. So those two lines will never cross. Therefore, there is no solution. And that is called inconsistent. I'll get my blue one. So these, let's add this as well. These are called consistent. And so is this one. The ones that have any solutions at all are called consistent. And when they don't have any solutions, it's inconsistent. Now the consistent then can be further broken down into independent, where there's one, and dependent when there's infinitely many solutions. So this is going to take just a little bit. If there's something you're going to study in this chapter, it would be this and understanding this. I put this information up here. I tried to rewrite here because I know visually sometimes different things jive with different people. So I also wrote it here. So a consistent system has at least one solution. I'm trying to grab this paper and it will not move. Okay. right? Because a consistent system has at least one solution. Independent, right here, is when it has one solution. Dependent, right here, is when it has infinitely many solutions. And inconsistent, it doesn't have a dependent or an independent. That classification doesn't go with this one. When they're parallel, there's only one word to describe it, and it's called inconsistent. And there are no solutions. And, it's hard to memorize all this stuff. The only thing I was trying to find, little tricks of the trade here. The only one I could find was no solutions, is the word no. I don't see in any of the verbiage here anywhere else that it spells out no, except right here. No. I don't know if that helps or hurts. Take it for what it's worth. But if you're trying to think of something to help you memorize that the inconsistent one is the no solutions, the parallel ones, the word no is right here. Here it goes backwards. See, no goes backwards. That's not even a no. So anyway, so that's that. At the bottom, yet another way to have it all together. So this is the classification. So in your homework, when it says, what is the classification, they're asking you for these words here. Okay, and again, they are up here as well. This is kind of repeat 3. One way to think about it, another way to think about it, and then all of it in a graph. So you can use whatever one works the best for you. This one adds a little description with it, which is going to be helpful when we get to the back side of this. But I just want to review that the consistent two are right here. I'm just going to draw a line separating them. We got the inconsistent, the no solutions, the parallel lines. Okay, and parallel lines are going to have the same slope, right? But different y-intercepts. When they're consistent, that means they have some sort of a solution. In this case, they just have the one where they cross. But in this case, they have infinitely many because they overlap. So it's infinitely many. So as far as the description, these have different slopes. One's positive, one's negative. They're not even, they'll be the opposite there. Whereas here, these two have the same slope and the same y-intercept because it's the same line. So let's flip it over and practice, okay? So keep that. See, mine's on a separate sheet. I don't know if yours is. I think yours is too. So you can keep that page open right next to you there as you get used to this. And let's do this. Example 1, show that that system, again, system means more than one, system of equations has no solution, NO. What was the name for that? Inconsistent, good. And what kind of lines were inconsistent lines? Use your sheet if you need to. Parallel lines, good. Now what do we know about parallel lines? Let's keep going with this. The slopes are equal. And that's where we needed to get to. You needed to kind of get and have a full understanding of this because we need to be able to look in here and say, hey, what are the two slopes? So we're going to write this down, y equals x minus 4 and negative x plus y equals 3. And we're going to check the slopes. Our general form for a line, as you remember, is y equals mx plus b. So the slope in this one is, new color alert here, 1. So let's see what the slope is here. We can't tell yet because it is not solved for y. So I need to move the x over to the other side. So I'm going to add x to both sides. Y equals x plus 3. All right. And what is the slope here? 1. So, show that it has no solutions. Okay. They are the same slope. Yay. So, because slopes are equal, then lines are, well, actually, we got to check one more thing. I'm just realizing this as we're saying this. Because if this, it could have infinitely many solutions, because the slopes are equal. Let's just take note on this. The slopes are equal on two different ones, right? The parallel ones and the one where they overlap. So we got to check the y-intercept, because the y-intercept is the same. Then we didn't do it. What is the y-intercept on this? -4. Good. What's the y-intercept on this? 3. Good. So they are different intercepts, so they are not the same line. So because slopes are equal and y-intercepts different, then the lines are parallel. So there are no solutions. Now, do you have to write all that? Not necessarily. I'd love for you to be able to just do your work here and show me the slope and the y-intercept. You can just say slopes are equal, y-intercepts are different, so there's no solution. Now, let's go to the next one. Show that there's infinitely many. Okay. So is that consistent or inconsistent? It is consistent, because the only inconsistent one is the one with no in it. Inconsistent. And if it's infinitely many solutions, that means that it was a line on top of itself, right? So you should have the same slope and y-intercept. It should be the same line. It should be exactly the same. So let's look. First one, y equals 3x plus 2. Slope is 3. Y-intercept is 2. All right, let's take a look at this one. 3x minus y plus 2 equals 0. Again, we got to solve for y. And in this case, I see that the y is a negative. So instead of moving these two over here, I'm just going to move the y over. So I'm going to add y to both sides. And then I'm going to put it over here. So y equals, I'll put this over here, 3x plus 2. I think you guys hopefully followed me. If not, I'll rewrite it here. 3x plus 2. And then I just switch sides. So slope is 3. Y-intercept is 2. Yay, they're the same. Okay, so you can say same slope, same y-intercept, so same line, infinitely many solutions. Whoopsie. All right, a couple more to go here. There's two parts to this. We had to classify. Remember what I said classify was? You're telling me what it is. Independent, consistent, dependent and consistent, or inconsistent. Okay, actually those are probably more clearly listed right here. Here, here, or here. You're writing one of those three things down. Okay? And give the number of solutions. So in order to determine that, we need to get these into y equals mx plus b form. So I'm just going to put that up here, y equals mx plus b. So we'll do the first one here. I'm going to just rewrite each equation side by side so you have it real clear. and then negative 1/3 x plus y equals 1. Okay, so now we're going to solve for the y. How do we do that? Divide all of it by 3. Good. Now when I rewrite this, remember what's before the x? A 1. So 1/3 x, you can write it like that, plus the 1. Now we're going to go over here, we're going to solve for the y, so I got to get this term over here. And write the x term first. Oh, well, what do you notice there, people? Come on now, that's pretty darn exciting. We've got two equations, and now that they're both solved, we can see that they have the exact same slope. They have the exact same y-intercept. What does that mean? It's the same line, people. So if it's the same line, how many solutions? Yes, yes, infinitely many. So let's classify. So let's look back over here to classify this. The same line, same slope, same y-intercept, infinitely many solutions was called consistent and dependent. So your answer should say consistent, dependent, and infinitely many solutions. That is the answer. All right, next up. So go and copy your problems side by side so that we can have a good comparison of what's happening here. Solve for y. Minus x, minus 4, minus 4. There's my two equations. What do you see? I see something's the same and something's different. What's the slope in each of them? -1 and -1. So we have slope is equal. What about the y-intercept? Y-intercept is different. 5 and -4. What kind of lines are they? Same slope, different y-intercept. Very good. Parallel lines. So again, we're going to classify. So we can use this till we get more familiar. Remember, the parallel lines with the no solutions are inconsistent. So this will only have two things. Inconsistent, because there's only one word there when they're parallel. And the number of solutions is no solutions, or 0. All right. Lastly, new color. Let's see, what shall I do? It's just such a hard decision here. I guess I'll do blue because I don't want to do blue. Orange. I found an orange. Y equals 4 times x plus 1. Y minus 3 equals x. Solve them. Okay, so you can't leave it like that. You can just do the 4x plus 4 distributed. And this one, just move my 3 to the other side. Or your 3, or whoever's 3 it is. And we have that. Okay, so we have different slopes. So what does that mean? Yep, it's going to be a normal one like we've solved multiple times where you have two different lines and it's different slopes, and you're going to have one of these. So it's going to be this bottom one here where they intersect once, and consistent and independent. It's hard to remember these, so for now just use your sheet to help you. And also, how many solutions was that? Right, one solution. All right, good. So lastly, we have example 4, and there's a table somewhere in the book, I think, but I just will write it down here because I copied it down. I don't have the book here. Jared and David both start a savings account in January. If the pattern of savings in the table continues, when will the amount in Jared's account equal the amount in David's account? So I don't know if sometimes I realize I didn't write something down and add it to the main thing. So you might have this, but January, February, March, April, May. And then 25, 40, and 30, 45, and 35, and 40, and 55, and 45, and 60. Well, let's take a look here. Can we get an equation for these? Can we get an equation for Jared and an equation for David? I bet we can. Because remember, the intercept that's where you're starting. That's the 0 on a graph. Right? So the y-intercept is like, if you're thinking of, the number of months, you're starting at 0 here. So when you leave the y-intercept, how far do you go? That's, how much money are you putting in there, right, on day 1? Are you putting in there 5? Are you putting in there 15? Where on here are you starting? So in this case, we're starting at $25. So that's going to be my y-intercept. And in this case, he's starting with $40. And then we just need to get the slopes for each. And that's the rise over the run. So it's like, how much money are they putting in over, how many months are in between here? January, February, March, April, May. So they're going by 1 month intervals. So this person is going up $5 each month for 1 month. So that's a slope of 5 over 1. This person, they're also going up $5 for every 1 month. So that's also 5 over 1, or just 5. Well, what are you thinking? You got the same slope. You got different y-intercepts. What kind of line is that? Or what kind of lines would that be? Good. Parallel lines. So do parallel lines ever meet? No. So they will never be equal. They'll never have the same amount. And that actually makes sense, I'm sure, logically to you as you're thinking about it. You're starting here, you're starting here, and they're all continually adding the same amount. It's never going to be the same. It might be the same in different months, but not in the same month. So that would be your answer. That's all she wrote. So you guys can take the rest of the time there, and I expect you to work hard and show all your work and use that paper as a resource. Okay, I can't remember if I have a chart or not that I let you use for the test. I believe I do, but it doesn't help if you still don't understand what's on here, right? So work with it, and yeah, we'll see you tomorrow. Bye-bye.